into 3 different parts. We're going to be focusing on special types of functions and what their graphs look like. So if we think about what we are used to graphing, we're used to graphing linear functions. Put it in slope-intercept form, graph your y-intercept, complete the slope, make your line. Or find your x and your y-intercepts, graph your x-intercept, graph your y-intercept, connect them to make a line. So we're used to making a basic linear graph. Well, now what we're going to do is we're going to take these linear graphs and we're going to turn them into special linear functions. Okay? So, first and foremost, you don't need to put this because I know you know how to do this. Do we know how to graph y equals 2x minus 1? How do I graph it? You just tell me how to graph it. Start where? Start -1 and do what? Up 2 over 1, and I can do that as many times as I want. If I wanted to go backwards, I would go down 2 over 1, down 2 over 1, and then I would have a nice straight line, right? Okay, so if that is my graph, how many points are on this line? An infinite number of points would be on the line. What would be the domain of this line? All real numbers. What would be the range of this line? All real numbers. What if I did this? Did my domain change? Now what's my domain? -1. Think x. X-axis. Yeah, it's all real numbers, so going smaller to 0. So if I had to write this out, it would be everything less than or equal to 0, right? For my domain. Right, your range would be y is less than or equal to -1. What if I made it go the other way? So my line continued up like this, and I took off the bottom half. Now what's my domain?
The signs are changed the same.
Yep, my signs are not going to flip. So x has to be greater than or equal to 0, and y needs to be greater than or equal to -1. Okay? So as we think about this linear graph as a piece of the whole entire line, it's going to have a different set of domain and a different set of a range. So let's go ahead and graph this for the following. If we had the line y is equal to 2x minus 1, and I only wanted a piece of that graph so that my domain was for all sets of values of x greater than 2. Give you a second to get yourself set up. So if I were to graph it for the domain of all real numbers, that would just be a nice straight line. Put arrows at the end of it, call it a day. But now I want to think of it as just a piece of that line, a section of that line, for x greater than 2. Now you can visualize in your head what that graph looked like. It was kind of looking like this. But I want all values to be greater than 2. So am I going to have any part of the line over here? No. Where is your x values greater than 2? Well, here and all the way over, right? So where would I find that cutoff point, or that end point? At 2, what is the y?
2, 3. Oh, it's 2, 3.
When you plug it in, what do we get? So when x is equal to 2, what's your y equal to? Well, 2 times 2 is 4. 4 minus 1 is 3. So can we plot that point? Sure. 2, 3. Should I make that dot an open or a closed dot, do you think?
Open.
Why am I going to make it open? It's not equals to. Very good. So I don't want to include the value of 2, but I want to start at the value of 2. So from that point, what am I going to do to continue the line? Yep, just follow our slope like we did before. Up 2 over 1. Up 2 over 1. Connect. If I thought about it, if I did it backwards, down 1 over 2, down 1, don't do this in your notes because this is not right. it would just be the whole entire line, right? But I just want a piece of that line where my domain is larger than 2. Is my domain larger than 2 there? Sure. Let's flip it. What if I turn this into x needs to be less than or equal to 2? Then what part of the line would we have? Where does my line get less than? It's going to be the down part, right? There we go. What's going to happen with the point? It's going to close. I need to include it now, and I'm going to get rid of that top half. Okay? So if we change the inequality sign to less than, then I want the bottom half of the line. If I make it an equals to, then I'm going to include the point at 2 and make it a closed dot. So what we're doing is we're taking a chunk, or we're taking a section, or we're taking a piece of a function. In this case, it's a linear function. And when we take a piece of a linear function, we're going to create a special function, which is called a piecewise function. This is the only one we're going to focus on today, is piecewise functions. We'll get to the other ones tomorrow. So, a piecewise function consists of different function rules for different parts of the domain. So what's going to happen is I'm going to give you a bunch of linear functions, but then I'm going to specify a certain domain for each of those individual linear functions. So it's pieces of a bunch of functions put together onto one function. Okay, so piecewise functions. Are you ready for this? It's going to get crazy, but fun, maybe. For me, yes. For you, maybe. Are you ready? All right, here it is. Look at that fanciness.
What is that?
It's so ugly. It's not ugly, it's beautiful.
You're supposed to write that down.
So this is your piecewise function. Let's just get that written down. So this is function f, but function f is being broken up into really 3 different functions. And you use a little brace to hold them together. After each of your expressions for the function, they're going to state the domain for that function. So if I were to speak this out loud, I would say f of x is equal to 2x if 0 is less than or equal to x, less than 2. F of x is equal to 4 if 2 is less than x, less than 4. And f of x is equal to negative 1/4 x plus 5 if 4 is less than or equal to x, less than or equal to 6. How can I first determine whether this is a function or not? Do I have any other overlapping x values? Right here, what numbers are represented in my domain? 0, all the decimals between 0 and 1, all the decimals between 1 and 2. Is it including 2 here? No. Is it including 2 here? No, it's not. It technically should be. Let's add that. Include it. So here it's including 2, and then everything between 2 and 4, is it including 4 here? No. Is it including 4 here? Yes. So this would be a function because I don't have any overlap. If I would have had multiple equal to's at a specific number, like I just added in there, then it wouldn't be a function because then you would have 2 different values occurring there. Okay, so let's practice just evaluating numbers for this function. So we know function notation. We've seen this before, but now we just got this crazy function to deal with. So if I wanted to evaluate function f for 1, I need to figure out, well, where does that 1 fit into the domain? Does it fit into the domain in our first, second, or third domain set? First. 1 is in between 0 and 2, right? So since 1 is in between 0 and 2, I'm going to plug in the 1 with that matching expression for x. Well, what is 2 times 1? 2. So f of 1 is equal to 2. Now let's go to 3. Which line does 3 fit into the domain? The second one, that's in between 2 and 4, right? So now let's look at the expression. Is there any x there?
No.
So it's just going to be 4. I don't have anything to plug it in for, so it's just going to be 4. How about 6? Where does that one fall? Into the third one. So now we got to plug in 6 in place of x there. Now I got to think a little bit more. It's probably not going to be as nice. Negative 1/4 times 6 is negative 3 over 2. Yeah? Negative 3 over 2 plus 5. That's negative 3 over 2 plus 10 over 2. So it looks like we get 7/2. Did I do that right? I think so. Hopefully. So f of 6 evaluated is 7/2. Okay? So far, so good. Yes? Okay. Moving on. Moving on in the world. Now let's actually graph. It's the same one, so you don't need to rewrite anything. So now we're actually going to graph that same function. So how do we graph it? Now just watch. Don't put anything into your notes. How do I graph 2x? Where do I start? Start at 0, then I do what? Up 2 over 1. Don't put this in your notes because I'm going to do the whole entire line just so we get the point. Oops, wrong one. Down 2 over 1, down 2 over 1. So there is the line for y equals 2x. But I only want it for the domain for 0 to 2. So what piece of that line am I interested in? What's my leftmost endpoint? 0, 0, right? What's my rightmost endpoint? 2, 4, because I'm going to go all the way to 2. What's going to happen to my dots at those 2 spots? Open or close dot?
Close for the 0, open for the...
Open at the 2, 4. Why am I making that open?
Because it's not equals to.
Right, and then I would get rid of the rest of the line. So how can I get straight to this right away without graphing the whole line and then erasing things? Where does this 0, 0 come from? The 0 in my domain. If I think about these as 2 ordered pairs, left endpoint, right endpoint, think geometry or line segments, if that is my x coordinate for 0, plug in your x. What do you get? 0. So this is what I always do. I'll put little ordered pairs above it. Is this going to be an open or a closed dot? At 0, 0. It's going to be closed because of the equals to. So then I'll put a little close there. Just to remind me what I am doing. Organize my thoughts. Now let's go to the right endpoint. If x is 2, what's my y? 4. Is that going to be an open or a closed dot? That's going to be an open dot because it doesn't have an equals to. So then what I would do is I would go over to my graph. I would put a closed dot at 0, 0. I would put an open dot at 2, 4, and then I would connect. Okay. So now let's go to the third or the second tier. Keep that equals 2 there. Well, this one's easy. My left endpoint is 2. When I plug 2 into this expression, what comes out? 4. There is no x. When I plug in 4 into this expression, what comes out? 4. Can we plot those points? Yeah. It just so happens that this 2, 4 is the same as that 2, 4. So now what's going to happen to that dot? Now I'm going to close it in. 4, 4, open or closed? Open. Connect.
It's not O4.
Oops, thanks. It's 4, 4, thank you. 4, 4, so it's going straight across. All right, let's do the third step. So now let's plug in 4. When we evaluate the third expression for 4, negative 1/4 of 4 is negative 1. Negative 1 plus 5 is 4. When I do the same thing for 6, what did we say we got last time? 7/2. So at 4, 4, what's going to happen? I'm going to turn that into a closed dot. At 6 and 7.5, so 7.5 is a 3.5, so I'm right about here. Close dot and connect. There's my piecewise function. Looks a little bit crazy, huh? What would have changed if I would have changed this domain to just, let's say, x is greater than or equal to 4. Then it would just turn into an arrow, yes. There wouldn't be an endpoint on it. Okay? All right, so piecewise functions. Do you want to try some on your own?